Hello guys, so let's start with the last question. So yesterday we have solved stack problems and we are left with the one problem. So largest rectangle in histogram. So this is the last problem in the stack part. After the stack we will start with the binary search. Okay, so question is largest rectangle in histogram. Given an array of integer height representing the histogram bar, where the width of each bar is 1, return the area of the largest rectangle in the histogram. Okay, so basically we are given this array. So this array represent height of the bars. 2 height for this bar, 1 height for this bar. So this is a bar. Basically this is a histogram. So in this histogram, we need to find a rectangle with the maximum area. So for this particular question, 10 is the answer. So basically, why 10 is the answer? We have taken this area. So width of this area is 2 unit as width of one bar is 1. So we have two bars here. So width is 2 and height is 5. So 5 into 2, 10. So this is the histogram with the maximum area. Okay. So similarly, we have a histogram 2 and 4, 2 and 4. Okay. So here also, uh, if we take this histogram, its area is 4, and also there is another possible solution. We can only take this bar. So basically, 4 is the height of this bar and 1 is the width. So 4 will be the area. So here 4 is the answer. Okay. So uh, let's start with the brute force approach. So okay. For example, we want to make a histogram having this bar containing this bar. So, we if we want to expand to the right, we cannot expand because there is no histogram of the this height. So answer will be 2. Then suppose we want to make a histogram using this bar with the height 1. Suppose we try to make the bar on the histogram on the left side. So this histogram is possible on the left side, and on the right this histogram is possible. So basically we can make this histogram, uh, 1 2 3 4 5 6. 6 into 1, 1 is the height of this rectangle and 6 is the width. Okay, and this is 5. Okay, so suppose we want to expand it on the right, we cannot expand as height on the left is smaller than 5. Okay, we want to expand it on the right. Yes, we can expand it till here. So in this case the uh, area will be 10. Now 6, we want to expand it to the right. No, we cannot expand. We want it to expand to the left. No, we cannot expand. So here answer will be 6 itself. We cannot include other bars. So in the case of this bar, we can expand it to the right. Okay, this histogram, and we can also expand it to the left till here. Okay, so one, two, three, four. We can expand it to the four bars. So four into two, eight area we can form using this bar. Okay. So one observation here is we are stopping when we find a number smaller than this two. Okay, means smaller than our current bar. For example, in the for in the case of six, we will stop here because five is smaller than six, and we will stop here. So basically, we will stop whenever we find a bar smaller than the height of the current bar. So basically, we need to find a bar for the first bar minimum on the left side of the current bar and minimum on the right side of the current bar. Let's first start with the brute force approach. We are iterating every bar. Let's define our max area variable. At the end, we will be returning max area. Okay, so currently we are standing at ith bar. Okay, so first we will move left to this bar. So moving left for int L represent moving left. L is equals to L minus 1. L greater than equal to 0. L minus minus. Okay. Let's define our current area as 0. As our current area is the uh, height of the current bar. Okay. So we will move left. If our left bar left bar's height is smaller than our current bar, we will simply break. Otherwise, we will add it to the current area. Okay, we will add actually minimum of both. We will add this height. Okay, so we will move to the right. Now we'll move our I pointer to the right. Right, starting from I plus 1, r smaller than n, r plus plus. If height of my right bar is smaller than height of my ith bar, I'll break. So basically, we are using similar conditions, and my current area will be height of my ith bar. So we have calculated current area. So my max area will be max of my max area into my current area. Okay, and at the end I return the max area. Let's try running this code. Okay, so mm, okay, so basically the complexity of this solution will be Let's write down brute force approach here. Its complexity will be big of n square because for every I we are moving to left and right part of the array. So this will take big of n time and outer loop will also take big of n time. So in total we will have big of n square time. Okay, but constraints of the question doesn't allow us to solve it in n square. We need to solve it in somewhere n log n or big of n complexity. So we have to think of a better solution. So as we have a observation that in order to calculate area including this bar, for example this bar, we need to find the first minimum bar with the minimum height on the left side. For example here we need to find one, and also in the right. So here in the right we don't have any bar. So suppose imagine a imaginary bar here. So difference of this part into height of current bar will be my answer. So I need to find left minimum and right minimum. Okay, so we need to maintain a monotonously decreasing stack. For example, for 2 I add 2, for 1 I add 1 to the stack, as this is monotonously decreasing 2 1. For 5 I will not anything, monotonously increasing basically. 5 6 case of 6 till I reach a point. Okay, index of left minimum and index of right minimum. Okay, so let's initialize the stack. So we have a stack of integer. We will store indexes in this stack. New stack. We need a array left minimum of size n. Means index of the element on the left side. So let's start. While my stack is not empty, I will pop greater elements from it. I need to maintain a monotonously increasing array. Okay, so while my this is greater than or equal to my heights, height heights height value, I will simply pop from stack, and at the end if my stack is empty, my left min of ith value will be, if my stack is empty, then I will put -1, otherwise stack dot peak index. Okay, so let's just print our left min array. So basically, there is a concept in finding left smaller element, right smaller element, next greater element, next smaller element in this stack. So int element in left min string dot output print element. Okay, we are getting all -1. If my okay, we also need to add element to the stack. Stack dot add current element. Okay, we need to store index. Okay, so for this example here, what's the minimum element to the 2 on the left side? So there is no minimum element to the left. That's why we are returning -1. What's the element to the left of 1? There is no element to the left of 1 which is smaller than 1. Okay, so what's the element, first element to the left of the 5? So we are returning index which is 1. So 1 is present at the 1 index. So element smaller than 6 of the smaller than the 6 on the left side is index 2, basically 5. So element smaller than 2 on the left side is 1. Um, so 1. Element smaller than 3 on the left side is element at fourth index, which is 4. So basically, our left minimum is storing the first minimum element to the left of the current element. Okay. So now we need to find right minimum. So we will use similar code to find the right minimum. We will start from right and we'll go till 0th index. And if we haven't found any element, instead of returning -1, we will be returning n. So this will help us directly calculating the area. Okay, so let's just say if I take this array and I take an element which doesn't have any minimum element on its right side and also on the right side. So in the case of 5, our left minimum will store our left minimum of 0, 1, 2 of 2th position will be -1 as there is no element minimum to the left of the 5. And also our right minimum of the 2 will store n is 0, 1, 2, 3, 4, 5. So size of the array. So in order to calculate area formed by this 5, if we calculate it is 5, 5, 5, 5, 5, so 25. So how it will gonna help us? Mm, right min of 2 minus left min of 2, which is 5 plus a 6. 6 we will be subtracting minus 1 and will multiply it to height of current bar. So that's why we are storing 5 here. Okay, so let's print our right min array. Okay, we are getting all zeros. If stack is empty, stack is empty, why we are not storing in here? Okay, we need to put the right min here. Okay, so starting from left, we will see if our stack is empty, write minimum of I of 4, 0, 1, 2, 3, 4, 5. So here answer need to be 6 for this value, but it's 4. Let's just debug it. This is right min. Okay, so initially we have stored index of n minus 1 in this stack. Okay, so we need to clear our stack as we are using same stack. I think this will work. Okay, so we have cleared our stack. So minimum to the right of the 3 is 6. Basically means 6 means there is no minimum element to the right of 3. 2 means there is no minimum element to the right of 2. In the case of 6, we are returning index 4. Basically 4 is the index of 2, so 2 is the minimum to the right of the 6. In the case of 5, we are also returning 4. So first element minimum to the right of the 5 is 2. Okay, so in the case of 1, we are returning 6. There is no element minimum on the right of the 1. So, okay. So now we need to find the maximum area of the histogram. So let's define. We have already defined max area as the 0. So we will do nothing. Our max area will be this itself. So instead of 2, we will put I here, and heights of current Let's try running this. Okay, let's try submitting this. Okay, we have found a submission. So uh, instead of using right min array, we know that we can calculate the answer here itself. We can calculate max area here itself. So basically, our max area will be right minimum. So right minimum. Let's wait a second. So we are returning this part. We are storing this part in the right minimum of I. So we will replace our right minimum with this formula. Okay, and we will just cut it from here and paste it here. So in this way, we don't need an extra right minimum array. Let's just run this code. Okay, so basically we have eliminated extra space for the right right minimum array. Okay, so we are done with the stack part also. So we have four solved four topics. Okay, we need to search in a 2D matrix array and cocoating bananas. So we will solve these two questions now. Mm, Okay, so you are given a m into n integer matrix with the following two properties. Each row is sorted in non-decreasing order. Okay, so we have rows sorted in increasing order 1, 3, 5, 7. The first integer of each row is greater than the last integer of the previous row. Okay, basically 1, 2, 3, 5, 7, 10. In this way, we have a sorted matrix. We are given a target, return true if the target is in the matrix, otherwise false. Okay. Okay. So we have a row wise sorted array, and also the last element of this row is smaller than the first element of this row. So basically we have a sorted array 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. And we need to find whether the solution exists in the array or not. Okay, so suppose we initialize the array with the size of a total number of element in the matrix. Let n be the number of rows in matrix and m be the number of columns in the matrix. This is the okay. I will iterate the matrix. J smaller than m, j plus plus. My array of what will be index I plus j. Okay, will be equal to Matrix of I comma j 0 0 1. This will not work. 0, okay, 1 1 0. Index will be n into I. So uh, initially I will be 0. So 1 2 3 4 0 1 2 3 3 will go till 3 index. Okay. After that n into I, n becomes 1. Sorry, I becomes 1. So 3. Wait. M into I. M here is 0 4 4 4 5 6 7 0 1 2 3 4 5 6 7 8. Okay, I think this will work. Let's try printing our array. Int element in array. System. Okay, so 1 3 5 7 10 11 16 20 23 24. So we have got our array. Now we need to find a target element. We will simply apply binary search. So this will take m into n time. Then we can apply binary search on array, and by applying binary search will take log of m into n time. Okay, so this is basically a brute force approach. We will be not using this approach. Okay, suppose we start with here. We need to find 3. In right we will be having maximum element. In bottom we will also have a maximum element. Suppose we start from here. In right we have greater element, we have smaller element, here a greater element, here a smaller element, greater element. Suppose we need to find 16. So we need the small element, but we need the greater element. We need the greater element. Okay, smaller element and smaller element. Okay, suppose we start from here. On this side smaller element, this side greater element. Okay, so I think we can start from top right corner or bottom left corner. Okay, suppose we start from int current. Suppose our I is 0, meaning I is equals to n minus 1, meaning this row, we are in this row and column is 0th. So while as we row is greater than 0 and our column is smaller than m, our current element will be matrix of row and column. If current element is greater than, if current element equals to target, I will simply return true that my element is present. But if my current element is greater than matrix of row and column, so I am here and my current element is greater than 23. Suppose I am searching for 34. So if my current element is greater, I'll move my column to the right. Basically I'll increment my column. And suppose I am searching for 5. So if I'm searching for 5, I'll move to the above column. Okay, above row, sorry. So in this case I'll decrement my row. I think this will work. Hmm. In first case, it is returning false. We are finding 3, so why it is failing? Suppose I'm here. 3 is smaller, so I'll move my here. Okay. Sorry. My target is greater. I'll need to compare target. Okay, let's try submitting it. Okay. I think I have previously also used the same approach. Let's see. Okay, I have searched in every row. In every row, I have applied uh, binary search. Okay, initial approach applying binary. Uh, this is the same approach.